Welcome to our deep dive into the fascinating world of solid-state physics. Today, we're unlocking the mysteries behind the materials that form the foundation of modern technology. From the vibrant screens of our smartphones to the intricate circuits in our computers, solid-state physics is at the heart of it all. But what exactly is solid-state physics? At its core, it's the study of solids, specifically focused on understanding their properties, structure, and behavior. The wonders of solid-state physics lie in its ability to explain how materials conduct electricity, how they are magnetic, and even how they can respond to light. Let's explore the basics. Solids are materials where atoms are tightly packed together. In the world of solid-state physics, we categorize solids into two main types: crystalline and amorphous. Crystalline structures have atoms arranged in orderly patterns, like in diamonds. Amorphous solids, on the other hand, lack this order. Think of glass as an example. One of the most critical concepts in solid-state physics is the electronic band structure. This refers to the way electrons are distributed in a solid, forming bands of energy levels. It's these bands that dictate whether a material acts as a conductor, insulator, or semiconductor. Conductors, like copper, have overlapping bands, allowing electrons to flow freely. Insulators have a wide gap between bands, restricting electron flow. Semiconductors, such as silicon, have a smaller gap, making them perfect for electronic devices as they can be manipulated easily. Why are semiconductors so significant? They're the backbone of all modern electronics. Adjusting their properties allows us to create transistors, diodes, and integrated circuits, the building blocks of our digital world. Solid-state physics also explains fascinating phenomena like superconductivity, where materials exhibit zero electrical resistance at low temperatures. This discovery has the potential to revolutionize energy transmission. As we continue to explore and understand the principles of solid-state physics, we open doors to new and transformative technologies that could shape the future. From sustainable energy solutions to advanced computing, the possibilities are endless. We hope this glimpse into solid-state physics has sparked your curiosity. Until next time, keep questioning the world of physics around you.